Uh, I work at YGA, Young Global Impact, as the Global Projects Director. YGA is an international NGO dedicated to advancing STEM and AI education with a focus on sustainability and social impact. So as university students joining us today, maybe some of you have already applied to the Global Sustainability Challenge. Some of you are thinking about applying soon, and maybe some of you are here simply out of curiosity about our distinguished session. And I'm sure today's session will be an inspiring one for all of us, and also will spark ideas to move forward. Before introducing our dear speaker, we have the founding partners of Global Sustainability Challenge with us today, institutions that have been shaping this initiative from day one. So I'd like to take a moment to thank our amazing partners, including Stanford Doerr School of Sustainability, Imperial College London, Technical University of Munich, Indian Institute of Technology Bombay, Zhejiang University, Hong Kong University of Science and Technology, Maker Bhavan, Maker Guts, and YGA. For those who haven't yet applied, I really encourage you to visit our website, globalsustainabilitychallenge.org. And after that, you can be part of this global community of driven young people who are using their skills to design solutions for the real world challenges. In these live learning experience sessions, you will get a chance to learn directly from people who have already created real world impacts. And today we have one of those inspiring leaders with us. It's my great honor to introduce our dear mentor, Sila Kiliccote, a global leader in clean energy systems, and she is partner at Breakthrough Energy Ventures. Sila combines her technical depth with visionary leadership and working on the integration of electrical vehicles, buildings, and also distributed energy resources while building high-performing cross-functional teams. With her diverse background as an entrepreneur and also an academic, she continues to drive innovation that bridges science, business, and impact. She serves on also several boards of technology companies. So Sila, it's such an honor to have you with us today. Welcome.
Thank you, Elif, and thank you to all the organizers for inviting me here to give this talk. And thank you all for showing up from different parts of the world. I appreciate you, and I appreciate your questions when time comes. Let me share my presentation. Let me just jump into what I'm going to talk about today. I'm going to give you a brief introduction. Actually, it's not brief. It's going to be not just about what I've done, but how I've done some of these things and how I'm doing with the parts of the team that I belong to, so that you get a sense of the insights, not just sort of a resume of things I've done. Then I want to talk a little bit about deep tech company building and some of the concepts that we look at as investors, and then what it takes to take it from 0 to 1. And just honestly, one slide on guidance for innovators, and then I'd love to take your questions. So without further ado, let's go to the next slide. I want to do a quick introduction and say the last words first. I just want to start with 3, and 3 is going to be the theme today. Everything I try to condense is going to be in 3s. So the first 3 things that I want to take away, and the only 3 things if you just close your laptop today and walk away, are that climate change is one of the biggest challenges of our time. I'm saying one of the biggest because AI is coming and it's going to have a huge impact. And the challenge is that we need to keep adding more energy to our systems because the poorest countries need to grow and they need energy to be able to do that, while we're also cleaning up the energy systems and leapfrogging their existing technologies. The second thing is that we need the best and the brightest people, not just engineers, but teachers, lawyers, doctors, politicians, to tackle this challenge. It's not something that we can tackle alone. It's not something that a country can do it alone. We need everyone's participation. And from my perspective, this needs to be a largely capitalistic effort. When you look at all the capital available in philanthropy or the governments and the cycles in governments, we need a steady stream of capital coming in from private sector. And just how the capitalism got us to this point, I think capitalism will need to take us from this point. Quick introduction. Elif already mentioned, I had actually 3 careers. I started as a researcher and became a scientist over time, and I worked in the intersection of buildings, electricity grid, and transportation. During my time as a scientist, I worked as an applied scientist, meaning whatever was developed in the lab, I wanted to see that it can be applied and be impactful in the real world, and that was really important to me. And probably my claim to fame as a scientist is the automation of demand response, what is now being also called virtual power plants. And I didn't come up with the idea, but I was instrumental in deployment and development of OpenADR. OpenADR is a communication protocol that communicates price and reliability signals from the grid to all the distributed energy resources. The second thing I've done as an entrepreneur, when I'm sitting at the lab and looking at my experience with OpenADR, which took about 12 years to get from lab to market, I thought I could do it much faster. And so I decided to leave the lab and become an entrepreneur. And the challenge I wanted to tackle was electrification of fleet vehicles. I wanted to accelerate that process and simplify that process for the adoption and quick adoption. And I'll talk a little bit about how. And then as an investor, I invest in companies that will reduce greenhouse gas emissions by 0.5 gigaton on the mitigation side. So we do mitigation investments and adaptation investments. And in our adaptation thesis, we're looking at companies that are going to save 100 million lives and ideally $25 billion annually. So with this, I want to go straight to my entrepreneurial activities, and I want to talk a little bit about what I've done that was unique, that was really helpful to the company that I built. Before I even started and we built the company in 2019, I took the summer of 2018 off, and I looked at the industry connections I had, 408, and made more connections, and conducted over 250 interviews. This is directly from a pitch deck that I did, my first pitch deck for the company. I also went to China and had 23 interviews with startups that were tackling the same issue. And then I went and did over 100 pain point interviews with the customers, potential customers that I would have. And then storyboard interviews where I took some concepts and showed them how they may impact their lives. And then actually build a prototype of a product that I wanted to build and show it to them. And so I'll walk you through a little bit about this journey. So this is what it looked like. We basically used a lot of Post-its as we were having conversations with these potential customers, the pain point interviews. This is where we were in a small office, about 5 or 6 people at a time, and doing interviews for over 12 hours a day. And then I visited fleets with my colleagues. These are some of the pictures I took in China because they had the highest number of electrified fleets at the time. I wanted to understand what their secret sauce was. And so I talked with public fleet owners and private fleet owners. Then, you have all this information, you have to structure it somehow. And so we developed these customer segments. Understanding your customers and building something that makes sense to them is extremely important. And I'll talk a little bit about that when we get to the company building side. Then I also wanted to synthesize the industry pain. What are the key industry pains? And which ones should I tackle? And which ones should I not tackle? Because it's not something that a technology solution can handle. And then in the ones that we wanted to tackle, we wanted to actually do deep dives and really understand what a technology solution may look like. And then is there a business behind those? So after doing all this homework, we decided to build a software. The software tool we called EIQ Evaluate. The idea is that you have an existing internal combustion engine fleet, and you want to take that all their information and see what an electrified fleet potential would look like for them, both in terms of cost, and the cost of the fleet was done with a total TCO. I can't remember now, drawing a blank, but we wanted to calculate the total cost of operation. That's what it is. And then we wanted to give them a CO2 emissions reduction number based on the electricity that they were using in certain places in the country. So with this product, we were revenue neutral within our second year, and we were acquired by a public company. So many call this a success story. What is a success story to me was that public company went ahead and built a whole team around this tool and was consistently delivering information to those fleets that were looking for converting their fleets to electric fleets. Okay. After I sold the company, I was thinking, what am I going to do with the rest of my life? I was committed to staying and building this company under this public company. But then I got a call from Breakthrough Energy Ventures. And Breakthrough Energy Ventures invests in technology innovation companies that will lead the world to net zero emissions. And for me, that was a unique opportunity to impact not from one company's perspective, but really tackling it by working with many different companies in many different areas. So as a person who's driven by impact, I thought this was the most impactful thing I could do. I want to tell you a little bit about the breakthrough energy ecosystem. 90% is the venture side, 10% is the philanthropy side. This is somewhat of an old slide, honestly, because we did add a grids group to breakthrough energy team. And the purpose of the grids group is to provide open source tools internationally so that anyone who wants to do grid analysis using these new technologies could do that easily and cheaply or free. Anyway, in this ecosystem, we try to really sort of motivate the entire ecosystem. So there's some basic research that comes out of the universities and labs that may be at a very small scale, and they need to be slightly larger scale for venture capital to come in and fund them. So Breakthrough Energy Fellows does that. They have now new cohort applications open. So please take a look at their website and see if your invention can be a part of that cohort and apply. They usually provide 2 years of funding with a SAFE, which gives them equity at the end of the 2 years when the company is formed and they are ready to go out and raise their seed or pre-seed round, depending on where they are. In an early startup stage, and as they're growing, the venture comes in. That's the capital that comes in, takes equity in the company, but also helps support the company throughout its life cycle. And I'll talk a little bit about those life cycles so you'll get a sense of where the venture money comes in. And then as the company is growing, there's a need for first-of-a-kind project financing. And the Catalyst was built to support that first-of-a-kind project financing. The issue with startups is that they're usually cash-strapped. They don't have a balance sheet to build their first-of-a-kind project. And because they don't have enough collateral and they don't have the history, it's really hard to get loans that are cheap. So the Catalyst program was built so that we can give inexpensive capital for the first-of-a-kind project so that we can help finance those. The y-axis is investment. So the investments are increased as the company matures, and the x-axis is the company maturity. So that's sort of the timeline. Okay, so how do we do this? How do we make investments? If you want to know a little bit more about how we do things, I think you should definitely read Bill Gates' How to Avoid a Climate Disaster book. The book is going into depth in all of these areas and how it was established and what we have been doing and how we've been looking at reducing climate change and reducing greenhouse gas emissions. But we invest in 5 areas, and these 5 areas come from the IPCC report. And they're the highest sectors that contribute to greenhouse gas emissions. Manufacturing is with 31%, electricity is 27%, 19% for agriculture, transportation 16%, and buildings 7%. We look at different innovations, and I will leave you with Climate Atlas that shows some of the maturity of these technologies in these sectors and some of the areas where there's still a lot of gaps. So I'll tie with this later. Okay, from our early understanding, we know that there are stepping stones for decarbonization, and this is understood and accepted globally. Again, there are three. We need to use less energy. This is through efficiency of components and systems, as well as conservation of energy. Then we need to electrify everything, switch to electric power from fossil fuels to electricity. And then the third thing is power everything with electricity as much as possible using renewables. So that's the decarbonization of the grid piece. According to IEA's 2021 net zero report, we need to increase the capacity of the grid from about 3,000 gigawatts in 2020 to over 10,000 gigawatts by 2050. Now, I just want to remind you that this report was from 2021, and lots of things have changed since 2021. The big thing that was changed is really the introduction of ChatGPT in November 2022. And since that time, there's been a significant improvement in AI and the tasks that they can take on. And what's really important about this is that all of this takes energy. And all of it is competing with the clean energy sources that we're trying to use for cleaning up the existing systems. That's something to be very mindful of as we're thinking about climate change. Okay. All right. The second thing is that we need to understand the growth of these AI data centers and their impact on the energy systems. And one of the things that we come up a lot is that, well, if you make them efficient, then you're not going to realize this 12%. But the important thing to understand is there's a thing called Jevons paradox. And what it says is improvements in resource efficiency lead to an overall increase in resource consumption. So even if we make these really efficient, doesn't mean that we'll avoid that 12% growth. We may still get there because more people are going to use it because it's going to be cheaper. And I just want to tell you one more thing about AI and data centers. As we're increasing the energy consumption, if we continue to use the existing resources, then we're going to increase CO2 emissions. So that's something that we need to be extremely mindful of and think about as we're thinking about climate change. And we're already seeing the increase in demand and increase in electricity prices, but they're very local and they have a very local and important impact. So the AI data centers are increasing the electricity price in the US, and in certain pockets where these data centers are being built, they're actually increasing the utility bills for consumers. They're having a real impact in our lives. Okay. That was the introduction, actually. I just wanted to quickly summarize. We need to use less energy. We need to electrify everything. We need to use as many renewables as possible as we're electrifying. And AI is another resource that's competing with clean energy sources. And we need to think about that. We need to do it fast. Now, I want to talk a little bit about deep tech development cycles. I think that's what we're here for. But before I even start, I want to again go back to Bill's book. In case I didn't tell you, Bill Gates is the founder of Breakthrough Energy. After building Microsoft and Bill and Melinda Gates Foundation, he's built Breakthrough Energy. And in his book, he talks about this concept of green premium. It is the additional cost of choosing clean technology over a conventional one. The best way to describe it is you have an apple, you can buy it for $1, and you have an organic apple that you can buy it for $1.20. That 20 cents is the green premium that you're paying for the organic apple. When we think about companies and investment in companies, we think about in terms of green premium. So there are three types of companies, and I know it's coming to be funny that I always think about threes, but there are those companies with products that are at or negative green premium. And that means that the organic apple in that example is either $1 or even less. So a negative green premium is that if that apple is 90 cents, so there's a 10-cent green premium, negative green premium. There are other companies that start with higher green premium at first, but get to negative over time. And that means that they need to figure out how to scale, and they need to, as they scale, lower the cost of those technologies. And some are obvious, but some obviously are not obvious. So there's a lot of work that goes into in terms of thinking through how can we bring the price of these products over time and make sure that they're at or negative green premium, at zero or negative green premium. And then there are those companies with products, no matter what we do, will have high green premium. There's no way that we're ever going to reduce them because they depend on a lot of different other factors. And this is just a graph that shows the three different types. There's the incumbent price, there's the entitlement, and on the right side, there's some sort of a thermodynamic barrier that does not allow us to get that at that green premium or lower. Okay, so let me now switch to the deep tech development steps. They're basically 4 steps, not 2-year cycles, but sometimes these cycles vary quite a lot. And I'll talk a little bit about that. The first stage is really the R&D stage. You have an idea, you want to build a company, the idea may have some risks associated with it, and you really need to de-risk it as much as you can. And in my example, we had an idea about accelerating and simplifying electrification. It was an idea, but we didn't know what our customers wanted. And so we needed to understand what the customers wanted and needed, which one of these customers would really, working with and solving their problem, which one would really accelerate the adoption of electric vehicles. Pre-seed, seed is an important stage because you really need to think about the de-risking of the technology and really understanding the product market fit. The second thing is really prototyping and piloting. So, okay, you have an idea, you think it's going to work, you may have done some modeling, great. You've had customer interactions, that's awesome, but you really need to prototype and pilot it. Does it work? Will it work at the scale that you're looking at? And then you have to think about commercialization. The stage 3 is really about commercialization. How can you produce it at scale while lowering the cost? And how can you sell it? And I'll talk a little bit about this as well. And then the last bit is scaling and mass production. Okay, so you have some customers that bought the first maybe 5 products or 10, or depending how big this is, maybe 1,000 products. Now you want to reach millions. And how do you actually do that? And in each stage, here I identified what the focus is, where the funding typically comes from, and some of the challenges that the teams have to overcome. Okay, so let's dig deeper into this. And I will tie this to a company that I work closely with called Doerr Energy. Doerr is building thermal energy storage systems. They are taking renewable energy, storing it as a thermal energy storage system in graphite, and then using that energy heat, 2000 C, to create steam, and then use the steam in an industrial facility. So that's what they do. When we're looking at the R&D stage, we want to understand if the technology is going to work, if there is an engineering magic that it requires or scientific magic. We're not interested as investors because we know magic doesn't happen. But if there's an well understood engineering challenge, and there are pathways to solving those that challenge, that's when we're really interested in that technology, in that company potentially. The first thing though, what we look at is the team. Is the team committed to building and scaling the technology? And in this case, you're seeing the 3 co-founders of Doerr, Justin, Andrew, and David. This is from their website, actually. And what's interesting is that this is a widely successful company. And instead of like crossing their arms and, just sort of posturing on their website. They're basically like showing their picture from behind because that's who they are. They're extremely humble, they're extremely capable, and they're extremely involved in every aspect of the business, especially building the culture, because that's what drives a lot of the recruitment, finding the best people into the company and recruiting them into the company. And honestly, the best investors and recruiting them into the company too. And in this R&D stage, the company was really looking at how are we going to build? Is the graphite right material? They looked at a bunch of other things. They've actually done some tests, and they actually used this furnace in another state to test their models in terms of the shape of the graphite and in terms of the material itself. And after this, they actually started raising money. They had convinced themselves that this technology will work. They had convinced themselves that this technology will have impact. And they had convinced themselves that this technology is going to be successful business. And so they were really focused on building this technology and putting all of their time and effort into this. And as an investor, of course, we also look at, is this technology going to perform in a big enough market for it to make a difference? The second step is prototyping and piloting. On the right, you're seeing the first prototype in a pilot facility of Antwerp as one of the units that they built. The first unit that they built, it didn't work right away. So it was designed so that they could get into the different places and change things and adjust so that we would get the most yield out of this first unit. And on the bottom on the right, the final version, the pilot is working today still at the site. Building a pilot and iterating it is not the same as building a reliable product, right? So we wanted to make sure that this one unit worked at the site, but the most important thing is that can we actually build this unit at scale, and can it work as promised for the duration as promised as well? One of the things that we needed to understand was, yep, this one unit is great, but how does the techno-economics work? And is the tech actually be scalable? Are the supply chains, in line and available so that we can actually build this over time, even though there could be some market fluctuations, as you know, tariffs are coming. The other thing that we were still thinking about, the timing is a big issue for these companies, is the market is still, as we're thinking about if the market's still big, we're also looking at timing issues. If we build it today, will the customers buy it? Do they need it? Do they continue to need this product? Okay. The third cycle is commercialization. Here on the right, you see these units now being built in multiples. And that means that we need to build a manufacturing plant. And manufacturing plants, in this case, it's a first of a kind manufacturing plant, but they require a lot of capital. They require that you get the capital to get the place, get the raw materials, and start building a team and streamlining the manufacturing process as you're optimizing each unit. So it's really important that you think about unit economics, you think about the industry evolution and pipeline, you need to think about how you can accelerate the manufacturing of these. And you need to start thinking about your brand. What is the brand you're trying to build in the marketplace? You should be the first you should be the first company that people call when they need something like this. The last piece is scaling and mass production. Here on the right side is a rendering of the project that the Antwerp folks are working on. This is going to be their first project, and it's going to be massive. And here the attention has been focusing on this project itself and focusing on many other projects as well, and really execution on delivering this project. Now, the founders were highly technical. They needed to build a company that now delivers to these projects. They really needed to understand the project finance piece. They need to build products that feed into these projects. They need to understand structuring of companies, and they need to attract the best people that can help them do this. So you have to, when you're building these deep tech companies, you have to really understand that your technology knowledge is only going to get you to a certain place. And you need other kinds of support, especially when you're thinking about the capital stack, other kinds of support that will elevate your company and help you grow basically painlessly, hopefully. And when you think about the sources of capital, it's very important for the evolution of the company. When you have an idea, you look at philanthropy or grants or government to support that idea until you have some sort of a proof of concept. Sometimes angel investors come in as well. These can be your family and friends or wealthy individuals that you know. And then once there's a proof of concept and the engineering risk is somewhat de-risked and there's no magic involved in the product development, venture capital comes in. We come in early, and we'd like to be alongside the entrepreneurs who are building these companies because we have experience from many different companies who have done this before. We have a huge network that can help support the company, both in recruitment and in capital stack understanding. And then as the company really grows, the private markets can no longer actually fund these companies. So that's why they go into IPOs and go into the public markets, and in many cases, as well as debt markets, to really get additional capital into the company to continue to grow and support the needs for their customers. All right, I am coming to the end fairly quickly. If you're an entrepreneur who's trying to or thinking about building a climate tech company, or if you have an idea and you want to understand how it fits within the existing ideas, there's a website called Climate Tech Atlas, and it is structured in a way that we think about it, but it also has greenhouse gas removal piece, because if we have 50 gigatons of greenhouse gas emissions today, CO2 equivalent, reducing carbon today is not going to be enough. Reducing all of the 50 gigatons is not going to be enough because we're going to stop at that point. But we have accumulated so much carbon in our atmosphere and in our soil and in our oceans. We really need removal technology as well. So the Climate Atlas is built around those 5 areas, but also greenhouse gas removal. In each sector, you can see the clear areas, their maturity, and some of the moonshots that are identified, and some of the gaps, honestly. So I highly recommend you go to this website and roam around and try to understand what has been done to date and what is needed to be done in these areas. And if you have ideas, think through those ideas as well. All right, I want to leave you with final words. So if you're planning to build a climate tech company or a deep tech company, I think you should know that building that company will take time. You see those 4 stages. As I said, each stage is not 2 years. You might have heard Series pre-seed, seed, Series A, Series B, Series C. The way that it happens in climate tech is usually there's seed plus, or seed 1, seed 2, then Series A plus, or A1, A2, sometimes A3, because it takes time to meet the milestones that get you to the next stage of the company. And so it takes much longer time to build these companies. So if you're thinking, it's like developing software that you can, churn the software, start selling it in day 2, and then start making money and then getting to IPO in 8 to 10 years. That's not climate tech. Climate tech takes a lot longer time. We have started investment in 2016, build the fund in 2016, made our first investment, I believe, in 2018. And none of our companies have actually IPO'd yet. So they've become great big companies, but they haven't exited in any way yet. Climate tech also takes a lot of capital. You really need to understand that there are different kinds of sources of capital. They come in different, I don't want to say costs, I don't want to say penalty, but each capital comes with its own cost. Venture funding comes with equity. You have to give up on the equity to get that venture funding. Banks will require you to provide some collateral and have some covenants, and it will have some interest rates on top of what you're getting. So the cost of capital it changes. And so you really need to understand, as you're growing the business, understand the sources of capital. And then building a deep tech company, sorry for the typo, will take guts. Every day is different. Every day will come with its own challenges and opportunities. You need to really have an even keel and really focus on what you're trying to do. The swings are really hard. There's going to be lots of ups and there's going to be lots of downs. And so you really need to make sure that you're up for this really interesting journey. But I can tell you it will be rewarding. Whether you are successful, you'll have success in terms of wealth. If you're not successful, you'll have success in terms of learning, if that makes sense. You're going to learn a lot about your leadership. You're going to learn a lot about some of the skills that you have that you need to continue to build, or you're going to really learn about your superpowers and your kryptonites. So it's going to be a very rewarding adventure, I'm sure. So I'll stop here and see if you have any questions.
Thank you so much, Sila. We are already seeing thank you messages coming in from participants. It's truly been an inspiring session. Thank you so much. While we're having the questions, like maybe I can start as you or a partner at Breakthrough Energy, hearing your perspective on what you look for in deep tech companies was incredibly valuable. We have one question, Sila. I think it's for your investor perspective, let's say. So deep tech investments usually have long return horizons. What metrics and indicators make a project attractive to you despite that?
Yes. So that's an important question, right? We know that it's going to take time. Why are we doing this investment? The thing is, of course, we want to see an impact. Half a gigaton is a huge impact. And if you can convince me that your company can have half a gigaton, that means it's going to be a huge company. The other thing is that when I'm looking at an investment, I really care about how big the total addressable market is or will be when this matures. If you're creating a new market, there's a lot of unknowns about the future. But if you can convince yourself that this is going to be a big market in the future, and you have all the thinking references transparently identified, and you can convince me, then I think that's really exciting to me. Because big markets means big impact. I just cannot emphasize it enough that impact and markets go hand in hand.
We have another question from an undergrad. As you said, building a deep tech company in climate will take guts and requires diverse skills, from developing innovative ideas to bringing them to market. As undergraduates, should we focus on deep technical expertise in areas like energy storage, or develop broader interdisciplinary knowledge spanning like engineering, finance, and policy?
I think being well-rounded in these areas will help you think through the problem. As an undergrad, honestly, you really need to hone in on some of the key skills. This is the one time in your life that you will have opportunity to focus on learning and learning things that you're really interested in. And so don't focus on grades. Of course, you need to pass but focus on getting yourself exposed to different things in your first couple of years and digging into those years in the next couple of years. In your third and fourth years. I think that's how I would rethink my engineering education. I was more of a broader person. I did a lot of different things And I did focus on optics and lighting in my last year. And until that point, until my last year, it was very much a broad electrical engineer, trying to understand controls, trying to understand communication, trying to really understand programming, as opposed to really focusing on one area. It helps you. For me, it was a good choice, knowing myself. It got me to really be a systems engineer. As a systems engineer, you really need to understand controls, communications, components, and systems. And that was really helpful. So depends on where your interest lies and who you are.
Right now, for like in this challenge, students also build up their teams. So we have a question about that. So as an investor, what's the first thing you look for in a team working on sustainability other than technical expertise?
Other than technical expertise, finance is important, as I said. None of these companies are going to be successful if they don't figure out their capital needs. If you're in a deep tech company, for example, you really need to understand working capital. You need to buy goods with cash you have on hand or cash you can borrow, and that you need to convert them into product and you need to sell them. Between buying the raw materials and converting them into a product, there's a time where you're not going to make any money and you will have to continue to pay your employees. So how do you ride that time and not run out of cash? That's very important. Companies die because they run out of cash oftentimes. And so you should try to avoid it as a startup as much as possible. So understanding capital sources, understanding finance is a very important part of all of this.
We have a question about every technology has trade-offs. So green energy solutions are crucial for decarbonization, but they have also environmental and ethical challenges like health risks from cobalt mining and solar panel waste ending up in landfills. Given these complexities, is net zero by 2050 realistic, or are we in an early phase where technological acceleration could make it achievable?
There's so many. These are just a few of the challenges. There's environmental challenges, ethical challenges, there's funding challenges, there's political challenges, as we know. So some days I wake up and say, what am I doing? This is never going to happen. It just doesn't make sense for me to spend all my time on this. And some days I wake up and realize that, oh my God, one of our fusion companies had a breakthrough. And guess what? If we can have abundant, cheap, clean energy, a lot of these problems are going to be solved. And I think that's sort of the up and down that I live as an investor, as an impact investor. And yes, we do not want to cause harm to the environment as we're trying to fix the greenhouse gas emissions issues. But honestly, humans have always exploited their environment. And there's going to be, unfortunately, some exploitation that's going to always happen. And sometimes we're going to take lemons and make them into lemonade. And sometimes we're going to throw our trash everywhere and we're going to clean up the environment and then try to find technologies to pick up that trash, right? So I don't think it's one or the other. We are very careful about the investments that we make in terms of benefits and costs to the environment. By the way, I started another camera. I'm not using my computer's camera. Hopefully this will work. Ooh, maybe not.
I think so. Yes, thank you so much for the questions, by the way. All of them are great. We have one more. Sila, I can ask that. Oh, that's a great question. So thank you so much for sharing your journey and about deep tech. How did you know when you had enough conviction to stop interviewing and start building?
Yeah, at some point, the people that I talk with, oh, sorry, this keeps going back and forth.
We can hear you very well.
Okay. At some point, you keep hearing the same things over and over from the same type of customers. So there's customer segmentation and there are personas within those customers. These are the people who are actually going to make sure that they're going to buy your product. So when you think about their pain point, and when you think about the organization's general pain point, you start hearing the same things over and over, then it just sort of says, okay, this is something that this is a real problem. This is a real pain point. And these are the personas in the same organization that are looking at it different ways, but actually articulating the same problem. And this is real, right? You can do it by numbers. We set it such that if we cure same problem 5 times, it's probably real from different organizations, and it has to be a diverse sample. But honestly, when you keep doing these interviews and you keep hearing the same things over and over, you're like, okay, 5 is not maybe enough. Maybe we'll do 6, 7, 8. And then at 10, you're like, okay, this is real. So even if you put some targets for yourself, you actually know when it really happens.
Where to start.
Some people, you understand it's the situation that they're in. They're thinking about it tactically. Some people, you understand, are really strategic thinkers and they're thinking about it strategically. Some people actually tell you what you want to hear, which is really interesting. And so you need to really, as the moment you start thinking through what you heard, you really need to think about what's real and what's not real. And actually, there's a science to figuring out what's real and what's not real when you're interviewing people. So, yeah, I read a lot about interviewing people and really synthesizing what I hear and making sure that I get rid of some of that bias. So putting artificial numbers, we did that. It didn't necessarily work. What was really working was a thoughtful review of what we heard every day after every call so that we can sift through. And honestly, being in a room and interviewing people with 5 other people listening in was extremely helpful because they heard things that I didn't hear because of my bias, or they heard things that I didn't hear because of their bias. So it was really helpful to have those interviews with other people in the room.
Yeah, that's a great takeaway. Thank you. And we have the last question. Oh, if you had to build another company in energy now, what problem would you solve?
This is a good one. Let's see. In the moment, the way that I think about it, there's an urgent buyer problem that we're living in. That is, the AI companies are really in need of generation. And that's one of the biggest bottlenecks for them. So they need to build more data centers and they need clean generation sources. I think I would build a company that generated electricity, converted into data in remote parts of the world, and then transported that data. Because if we try to build extra generation and the infrastructure that has to bring the electrons, that's going to take a long time. Building transmission is really, really difficult. We are not there yet to wirelessly transport electrons. But we can convert whatever we generate electricity, wherever we generate electricity, we convert that electricity into something valuable like data, and then ship the data that requires less and less expensive infrastructure. So that's probably what I would work on. Because I'm an electrical engineer, right? Like if you're a chemical engineer, you'll probably pick on something else. If you're a mechanical engineer, you'll probably pick up on something else as well. But this is definitely what I would work on. And then the other piece that I think about a lot is we have 70% oceans, and we're doing very little on the ocean. And so something on the ocean, around the oceans, with the oceans, I think there's a lot of energy and a lot of opportunity working in that surface, I guess, of the earth that hasn't been worked at yet.
Oh, thank you so much, Sila. And we answer all the questions. I am sending our regards for all the participants attending here today. And this recording will also be uploaded, will be available in our resource library. So you can revisit and reflect on it anytime. So before we wrap up, just a reminder that for those who haven't yet applied, please, I really encourage you to visit our website, globalsustainabilitychallenge.org, and hopefully we will have these webinars in the upcoming weeks. So please check it out, the social media of GSC. So thank you so much, Sila, for being with us.